friends, Mrs. Mapes here with another science experiment. Today we're going to learn about the water cycle, and the reason we're doing the water cycle is it kind of fits in well with what we've been doing so far with density. So remember last experiment we learned that heat changes the density of water, right? So hot water is going to be lighter and cold water is going to be heavier, right? So heat rises, cold sinks. Okay, so let's keep that in the background of our mind when we're learning about the water cycle today. Okay, so starting with number 1 on the scientific method is the purpose or question. So today we are going to ask a question of what happens to water on our planet, on Earth? How does it change form? And what is the water cycle? So we're going to hopefully have a better understanding about all of those things by the end of this experiment, right? The second part of the scientific method is to do a little background research, right? So I went on the web and I typed in the water cycle, and this is what I got. The water cycle describes how water evaporates from the surface of the earth. It rises into the atmosphere. It then cools and condenses into rain or snow in clouds. And then it falls again to the surface as precipitation. Okay, the water falling on land collects in rivers and lakes and soil and rock, and it flows back into the oceans. So where it once again will start the cycle again where it evaporates. I put on the Google Doc the information that we had from the last experiment too, just to keep that in the background of our minds. When water becomes hot, it's absorbing energy in the form of heat. The absorbed energy makes the molecules move and expand, therefore decreasing the water's density. When it gets to a point, it's going to actually change forms from water to a gas, okay? So the hot water has fewer molecules in the same volume of water, and this makes the hot water lighter. The opposite is true for cold water. The more dense the water molecules, the closer together they are. When the molecules are close together, they're not absorbing a lot of energy and they don't move as much, making them heavier. Therefore, cold water sinks. Okay, so again, this helps support the water cycle because heat rises, it's lighter, and cold descends, it's heavier. Okay, so going to the third part of the scientific method is the hypothesis. So we're going to propose a hypothesis. So today's experiment, if we add hot water into a bowl, it's going to hot water is going to form steam. The steam is going to rise up. When it meets a cold surface, it's going to condense, okay, and form back into water droplets, which will then drop down. So once there's a lot of water collected, a lot of water droplets is going to start precipitating back down to the bottom of the bowl. So the things that we need today. Okay, you need a large bowl. It says here clear. This is as clear as I got, but I can kind of still see through it. So it says semi-clear large container. We're going to need a smaller glass container or something that's heavy, because essentially we're going to be sticking it inside the large clear container. You're going to need plastic wrap. You're going to need salt.
Dye.
Yep, some food coloring, a spoon to stir, a tablespoon to measure some salt, and I'm going to be heating some water with my microwave. So I have a microwave safe dish that I can put water in to heat. If you don't want to do this method, you can also use a tea kettle on the stove or a pot on the stove. Make sure that if you're using the stove or the microwave that you have permission and that you have an adult supervision. Okay. So I think we have everything, Melody. I think we are ready to start the actual experiment. Okay, friends, I just wanted to give you a visual of hopefully what our experiment shows today. If our experiment is a success, this is the water cycle. And I attached this to the Google Doc so you guys can see this as well. But hopefully what will happen with our hypothesis today is that our hot water is going to evaporate up. It's going to rise up. And it's going to meet some cold air, right? Where our cloud is going to be, it's just going to be our saran wrap or our plastic wrap. And on top of where our cloud's going to be, it's going to condensate. All of the water is going to change from gas back to a liquid. Water droplets, it's going to collect. And once it gets heavy, then we're going to see precipitation, and that water is going to start coming back down where we're going to collect it, hopefully in our little glass jar. Also on my Google Doc, I posted a link to a fun YouTube song that teaches you about the water cycle. I always like to have a little with some science. So let's start our experiment. All right, friends, we are ready to start the science experiment. So we have the hot water, and Melody is going to very, very carefully pour the hot water into the container. If you are a little uncertain about it, you can always ask for help, but that water is very hot. Okay, so let's be safe about it. So next, she's going to add some drops of blue food coloring. You don't need a lot, 4 or 5 drops is fine. Okay, and then she's going to add a tablespoon of salt. We're going to make this water salty, right? Kind of like our ocean. Our ocean has salt water. Doesn't have to be perfect measurement, but just enough to make it salty. And then she's going to stir it all up. Perfect. So we have our ocean, right, Melody? Okay, so the sun has been heating that ocean up. Oh, we got to put our land in. Okay, so that's a nice dry bowl, right, Melody?
Yes.
It's in the middle of the large container. So there's our land in the middle of an ocean. All right, now it's time to add our saran wrap or plastic wrap. And when you're adding the plastic wrap, you want to make sure that you are covering the complete area of the bowl. So you're probably going to have to use several pieces of plastic wrap. So I had already tore plastic wrap for Melody. Be careful if you're using the box with the plastic wrap. Those little sharp metal teeth can cut you, so you might want to ask for some help. Plastic wrap does like to stick on itself, so go ahead and just put it down, Melody. It's okay. We can always get more out, right? And we discovered earlier that this bowl is plastic, so the plastic wrap does not really like to stick on it. So we're gonna actually have to use some tape, okay, to secure the plastic wrap down, because we want it to kind of be airtight in there, right? So couple of pieces of tape just around the sides to tape the plastic wrap down onto the bowl, because we're going to be adding the ice cubes into the middle of the bowl, and ice cubes have weight to them, right? So we don't want the ice. Water has weight to it, yes. We don't want the ice cubes to touch. This is our atmosphere up here now. Okay, we've created our atmosphere. Now we're gonna put the clouds, the cold clouds, on top, right in the middle. Just a handful. Doesn't have to be too many. Right in the middle of the bowl. That's probably pretty good. So there's our clouds. Okay, friends. So now what we're gonna do is we're gonna set a timer for 30 minutes. And we're going to just do some observation during that 30 minutes. We want to look at the top, what's happening at the top of the plastic wrap, and we also want to look at the side of the bowl to see what's happening on the side of the bowl. So, all right, friends, it's time to check our experiment. It's been 30 minutes. And Melody, can you notice, are there little water droplets at the top on the inside of our plastic wrap?
Yes.
Yeah. What about along the side?
A little.
Yep. Okay, so this might be a two-person job, friends, because we got to take the plastic wrap off without dumping the melted ice in it, because we want to see what ends up in our land, right? But before we do that, we're just going to kind of give it a little tap to kind of help with that precipitation, right? Getting those raindrops out of the cloud. Okay. And we're gonna very, very carefully, Melody, you take that side, I'll take this side. Wait. Because of the tape. Hold on, the tape. Okay, we're gonna take that off so that we don't drip any of that water. Okay. Now, let's get in there. Let's look inside there.
It looks like glowing green to me.
Okay.
Little.
Well, we definitely have blue ocean, but do you see blue ocean inside the jar?
No.
Does the jar look empty?
This around here.
Okay, so we're gonna take the jar out. Now, friends, do you see that? That's water in there, right, Melody?
Yes.
Yes? Okay, so that is our precipitation, right? Yeah, because the jar was empty when we put it in as land, correct?
Mhm.
Okay, so friends, does this water look blue to you, like our ocean?
No.
No. I wonder if it tastes salty, like salt water. Melody, you want to taste it? You want to be the daring one? Go ahead. Drink it, Melody.
That does not taste like water.
Does it taste salty?
No, it just doesn't taste like water.
Did it taste like anything?
It tastes like disgusting.
Oh, okay, but not salty.
No.
So it tasted like warm water.
Yes. But
Yeah, because we normally don't drink warm water, right? We like,
But it has like this disgusting taste to it.
but not salty.
No.
Okay, so friends, I would say that this is a success, right? So what is the last step in our scientific method? You remember? The conclusion, right? So if the hot water is like the water in the ocean, okay, the water takes on heat energy from the sun and it evaporates into the atmosphere. Once the evaporated water makes contact with the cold clouds, which was our ice cube, they're going to start the condensation process, which is the water vapors turning back into water droplets, right? Gas into liquid. When that happens and there's enough of them and the clouds get really heavy, then the water is going to condense and start dropping off, okay, as a form of precipitation. And then once that precipitation hits the ground, it'll eventually go through our lakes and our rivers and our streams all the way down back to our ocean. So I hope that you guys liked doing the water cycle with us, and we will see you with another experiment very soon.